Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we multiply complex numbers. So when we multiply complex numbers are actually something that we call modular arithmetic. So that means after they hit a certain point, they just repeat themselves. And that's because it follows a certain pattern. So what happens is I here is equal to the square root of -1. I squared is the square root of -1 squared, which is -1. And then I cubed is going to be negative I because it's -1 times I. Gives us negative I. Makes sense. I to the fourth is going to be 1 because that comes from our -1 squared, or negative I times I, which gives us a negative 1, which is a positive 1. So it follows this pattern. Then once we get back up to the next number, so I to the fifth, that's going to go back to following this pattern of the square root of -1. It's modular. That means it rotates through. It says once we go past 4, 5 is the same as 1, 6 is the same as 2, 7 is the same as 3, and 8 is the same as 4. And so we can use that pattern, depending on how far away they are from 4, to decide what is going to happen there. So let's take a look at what happens when we multiply. Now, when we multiply, what we're going to do is we're going to multiply the numbers on the outside and then multiply the i's and see what happens. So let's look at this first case. We've got 2 times 3, which is 6, and then I times I, which is I squared. But I squared is actually -1. So this is 6 times -1, which equals -6. Fantastic. Now let's take a look at this next one. We're going to multiply the first two. So I've got -6 times I squared times 5 times I. So I can either simplify this first one, or I can go through this whole thing here. I'm going to multiply these out. -6 times 5 is -30. I squared times I, well, it's just like our exponents. It's going to become I to the I cubed. But what is I cubed? It's negative I. So this is actually -30 times -I, which equals 30I. Perfect. So we can use this to multiply things that are 2 digits. Similarly, when we multiply, just like with radicals, we can multiply using the distributive property. So I'm going to multiply these by distributing them. So I get 6I, and then I multiply these two and you get -21I squared. But remember, I squared is the same as -1. So really we get 6I plus 21. And typically we would write that as 21 plus 6I because we usually write our real component first, followed by our imaginary component. Now let's do the same thing here with this one. We're going to multiply 3 times 5 to get 15, and 3 times -6I to get -18I. Perfect. There you go. Now, just like we could with radicals, we also can FOIL these. Now, this is super important because when we get to dividing in the next video, we're going to have to multiply by the conjugate, just like we did when we were doing operations on radicals at the beginning of the chapter, which required us to FOIL. So we want to make sure we know how to use the FOILing method when we have complex numbers. So I'm going to do 5 times 3, which is 15, 5 times -4I, which is -20I, 2I times 3, which is +6I, and then 2 times -4I, which is -8I squared. Then we need to simplify this. So I get 15, -20 plus 6 is -14I, and then we have -8 times -1. So 15 minus 14I plus 8. Well, these two can combine, and we end up getting 23 minus 14I. How fantastic is that it goes from 4 numbers down to 2? Let's do the same thing on this next one here. 1 times 2 is 2. 1 times 7 is 7I. -3I times 2 is -6I. And -3I times 7I is -21I squared. So then we have 2 plus I minus 21 times -1, because that's what I squared is. And we end up getting 2 plus I plus 21, which really is 23 plus I. Now, I feel like we are probably pretty good. If you want to try this next one, it's going to be super important because this is what we have to do when we do that conjugate. So remember, the conjugate means same first numbers, different second numbers, same third numbers. Okay, so the numbers are the same. The only thing that changes is our sign. So what happens when we multiply these out? Well, 4 times 4 is 16. 4 times 9i is going to be plus 36i. Negative 9 times I, negative 9i times 4 is going to be negative 36i. And negative 9i times 9i is going to be negative 81i squared. So then we end up getting 16. These two middle pieces cancel, minus 81 times negative 1. And then we end up getting 16 plus 81, which ends up being 97. So notice how typically when we FOIL, we go from 4 pieces to 3. But with imaginary numbers, we go from 4 to 2. When we multiply something by its conjugate, we go from 4 all the way down to a single number, which is kind of awesome. And it really helps when we divide because we actually can see what these divided numbers are. So that is how we multiply. Again, we're going to multiply the coefficient or the number in front and then multiply our i's. And then we're going to use our chart here to determine what happens to our i's. So again, if there's 1, that's the same thing as the square root of negative 1. And we typically just leave it as an I. If we end up getting I squared, we'll rewrite it as negative 1. If we have I cubed, we rewrite it as negative I. And if we have I to the 4th, that's just 1. So we want to make sure that we're rewriting that so our number can be as simple as possible and we do not have to have any radicals in it, which makes it really nice. So check out the next video in which we discuss how we can divide when there's an imaginary number in the bottom.